Hi guys, greetings of the day. Myself Raghavendra. Today we are going with design of spur and helical gear, third part. So in the previous part, we discussed about spur gear terminology and law of gearing. So today we will start with interference and methods to avoid interference. So first we'll understand what is meant by interference. Interference is nothing but mating of two non-conjugate teeth. So whenever a gear teeth are set to interference, then they have to overlap or cut into the mating teeth. Now this is the pinion, whereas this one is the rack. So the addendum on a rack is chosen in such a way that the first point of contact it will happen at E, which is the point of tangency for the line of action and the base circle of the pinion. The maximum length of line of approach is EP. So the maximum addendum which should be used on the rack is A. In order to investigate, that happens if the addendum of the rack were larger, and if it is a larger one, then it is a dash. If the pitch circle of the pinion and the pitch line of the rack were rolled to the right side, the rack and pinion tooth positions would be as shown with the help of dotted lines. And you can observe here overlap, that is interference is happened. Nothing but rack tooth overlap or interferes with the pinion tooth. In order to satisfy the fundamental law of gearing, it is necessary to undercut the pinion teeth. So as shown here, undercut. Undercut is nothing but removing some material. So this weakens the teeth and removes a part of the involute profile, which shortens the path of contact also. There can be no interference due to a large addendum on the pinion, since the point of tangency of the line of action with the base circle for the rack lies to the left at infinity. The maximum length of path of recess is PB dash if we consider the pinion teeth as a pointed one. Else, if it is a flat type, then it is a PB. If a rack mesh with a pinion without interference, then any finite external gear having the same addendum of a rack will mesh with the pinion without interference. We'll see what are the methods to avoid interference. So the first one is height of the teeth may be reduced. Next, the radial flank of the pinion may be cut back. It is called as undercutting. Center distance may be increased. It leads to increase in pressure angle. And the last one is by tooth correction. So next topic, it is a profile. So profile is nothing but the curve forming the face and flank. Basically, two types of profiles are used in gears. One is involute and the other one is cycloid. If the curve is of involute in nature, then the teeth is called involute teeth. So this is the involute teeth profile. And if it is a cycloidal in shape, the curve it is of a cycloidal in shape, then the teeth is called as cycloidal teeth. This is a cycloidal teeth. So comparison of involute and cycloidal teeth. First, advantages of involute teeth, involute profile. In involute profile, pressure angle is constant throughout the engagement, that is from point of commencement to point of disengagement. Whereas in cycloidal profile, the pressure angle is 0 at pitch point and it is maximum at the point of engagement and at the point of disengagement. Next, in involute profile, a small variation in center distance does not affect the velocity ratio. Whereas in cycloidal profile, the center distance should be maintained very accurately, else velocity ratio will change. Next one. In involute profile, the curve is a single curve, so it is very easy to manufacture. Whereas in cycloidal profile, the curve comprises of two, namely epicycloid and hypocycloid. so it is difficult to manufacture. So next, advantages of cycloidal profile. In cycloidal profile, there is no interference, whereas in involute profile, interference will occur. Cycloidal profile have spreading flanks, whereas involute profile have radial flanks. So cycloidal tooth is stronger than the involute tooth. And the last one is, in cycloidal profile, always one concave surface will be in contact with one convex surface. So the wear and tear will be minimum when compared with involute profile. Next topic, properties of involute tooth profiles. So which are the properties an involute tooth profile should have? So first one, a normal to an involute is a tangent to the base circle. Next, when involutes are in mesh, then the pressure angle remain constant, that is phi. The involute is the only tooth form which is insensitive to the center distance of its base circle. Means if center distance changes, velocity ratio will not change in involute tooth profile. The shape of the involute profile depends only on the dimension of the base circle. The radius of curvature of an involute is equal to the length of tangent to the base circle. Base rack for involute tooth profile has straight line form. Next one, the common tangent to the base circles of the two involutes is the line of action and also the path of contact between the involutes. When two involutes are in mesh, then they transmit constant angular velocity ratio, and it is inversely proportional to the size of base circles. Manufacturing is easy due to single curvature. Involute gears in mesh give conjugate action. And the last one, suitable for motion and power transmission. So next topic, systems of gear teeth. So to cut the gear teeth, we are using mainly three types of systems. The first one, 14.5 degree involute system. So here number of teeth to avoid interference is high because of low pressure angle. So these profiles are obtained by the gear generating process. Second system is 20 degree full depth involute system. Because of higher pressure angle, the number of teeth to avoid interference is less. These teeth are broader at the root and stronger. And the last type of systems are 20 degree stub involute system. In this system, the working depth is usually 20% less than the full depth system, and the addendum is made shorter. So the advantages of this system are low production cost, stronger than full depth tooth, less interference due to shorter addendum. So by comparing all these three, so with larger number of teeth, full depth or 14.5 degree involute system perform better than the stub involute system. So for this part, this much. So remaining topics we will see in the next part. Thank you. Please subscribe my channel.